Is there a question? Yeah, anyway, it's fine. So, okay, hi everyone. My name is Ken Hao, and today I'll be teaching Python coding. You guys can see the screen, right? And this recording will be up on the YouTube after this. So I will be, yeah. So don't worry if you're a bit lost during the course. And at any point in time, if you have any questions, please feel free to drop it in the chat or drop me a text on Telegram. I'll be more than happy to help. So the agenda for today will be variables, lists, and for loops. So what is Python? First of all, it's a programming language that is said to be the easiest for beginners to learn because of a couple of reasons. One is that there's a syntax, and another one is that there's an interactive console, which kind of lets you talk to the computer line by line of the code. And overall, programming is all about logic. And so don't worry if you're learning Python first, because you're not disadvantaged anyway, because you can easily learn other languages like C++ or Java, because the programming logic is all the same. It's just different lines, different things that you type. And overall programming is just a series of procedures for the computer. So like you're telling the computer to execute lines of code one by one in a manner to achieve whatever task you're trying to do. So resources wise, right, actually programming, there's a lot of resources online. It's quite abundant. But besides just resources alone, this is a very good resource. I learned most of my coding from the New Boston. Besides just the resources, which is the content, it's also very important to do hands-on experimentation. And in this course these first 3 lessons will be using this website, REPL languages Python 3. I just drop it in the chat right now. And if you go to the website, you'll see something like this. Yeah, if you visit this website, you'll see something like this. And you'll see 2 consoles. One is the one up here where you can type code, you can type multiple lines of code. And then when you press run, right, they'll be executed below. So for example, if I just type, this is the simplest program you can write, and I press Control Enter, or I press the green button up here, right, then the program will run and the output is in the bottom here below. Additionally, you can also type commands line by line over here. So when you see the yellow arrow over here is the whatever line you're typing, right? This is your input, and then whatever the code that you wrote, whatever output it is, it'll be outputted in a line here without the yellow arrow. So yeah, so there's 2 consoles. We'll be starting off with the bottom console over here, and then later on we'll be using this when we go on further. So in addition to that, I actually am working on this website where it's kind of like a Google Doc for code, and you and I can both edit. Basically, it's a virtual classroom, but we'll not be using it for this lesson, so don't worry about it. Okay, so without further ado, the first concept we'll be going on is to variables. And if you at any point in time, if any question, please drop in the chat, because I'll be more than happy if you ask questions, because if you try out yourself and you meet errors, then that really means that you're learning, and you learning makes me happy. So yeah, so if you learn, so that let's start with variables. So as some of you might know in algebra, right, if you have an equation, a variable is like it stores, the variable has a certain value that you usually don't know, and then you're given some hints about the variable, like x plus 2, x plus 1 equals to 0, and then you want to try to use some arithmetic manipulations to obtain the value for the variable, and that is variables in math. But I want you to forget all about the notion of variables in math, and because variables in coding is actually quite different. So instead, variables in coding in Python are containers of information. We think of them as boxes, right? They store information, and then you can replace the information in them, right? And manipulate the information to your needs. So for example, we started with our first 2 lines of code over here. So to create a variable, we just write the variable name that we're going to give it. So in this case, we name the variable x and we assign it the value 5, right? So you press and you write it in the console over here below. I invite you to try it out yourself, because it's only through typing that you really learn it. So you write x equals to 5, press enter, right? Now x is a variable. We've created a variable x that stores the value 5. So I go ahead and print x, right? So what the print function does is you type print like that, and you write open brackets, close brackets, and sandwich the variable that you want to print inside. And you press enter, you see that this is your input, right? This is your code, and then the output is 5, because x stores the value 5. So you see that yeah, that's basically how you create a variable. So now let's take a look at some examples. So one key, we see the first key difference between variables in coding and math, because if let's say I create a variable y, so create y equals to 3, and then I print y, I just get 3 as expected. Then I write y equals to 4.15. So now when I write y equals 1, y equals to 4.15, right? When I write this line and I press enter, now the variable y stores the new value 4.15, and whatever old value is stored is thrown into garbage. So what it means is that a variable is like a container, and whatever you store in the container can change as you write more lines of code. So you can alter whatever is stored in the container. So unlike math, where the variable is usually a fixed value, right, and it doesn't change, in coding, your variable values, the variable can store values that do change. So your variable's value can change when you do something like that. So the equal is an assignment operator that tells Python, hey, now I want to give a new value to y, and so Python will throw whatever is in the container, the y container, out of the window and replace it with whatever's on the right hand side of this. So if I go ahead and print y now, you see that the new value of y is 4.15, and Python has completely forgotten what is stored in the variable, completely forgotten about the number 3 because it has been replaced with 4.15. Okay, so that is the first lesson. The first lesson is that your variable is like a container that you can always that you can replace the value, and you can replace the value inside the container at any time. So the second lesson, we take a look at the second picture over here is, let's create a variable called 1. It's called x. We create a variable called x with the value 1. So we go and print x, we just get 1 as expected. Then we can write something like x equals to x plus 10. So if you press enter, you see that Python has accepted this line of code, and this might not make sense because in math, right, you take a look at it, right, x equals x plus 10, then you're like, wait, that's impossible because there's no value x that satisfies this equation in math, right? But the lesson to take away here is that the equal sign in math is not the equal sign in coding. So the equal sign in math is an assertion saying that the left-hand side must equals to the right-hand side. But equal sign in coding is an assignment of a new value to the variable. So when you have an equal sign in Python, the left-hand side will be the variable that you want to assign a new value to, and the right-hand side is the value that you want to assign to the variable. So in this case, you're writing the variable x, right? I want to assign it a new value using the equal sign to whatever's on the right-hand side. And what is on the right-hand side is equal. The right-hand side is x plus 10, which is 1 plus 10. And hence, this is effectively saying, correct. Yeah, this is effectively saying x equals to 11. So when I print the value of x now, wait, something went wrong, but I think we started. Let me just, so x equals to 1. Let me just retype it because I think something crashed over there. X equals to x plus 10, right? And I print x again, then I get 11. So the key lesson to take away in the second picture here is that the equal sign in Python is very different from the equal sign in math. In math, it's an assertion that the left-hand side is equal to the right-hand side. But in coding, it's an assignment of the new value on the right-hand side to the variable on the left-hand side. So yeah, that's the lesson for the second picture here. Now for the third picture, let's write x plus 1 equals to 3, okay? So in math, this would completely make sense, but you see that Python is complaining. It says that cannot assign to operator. So why Python is complaining is because when you write equal sign in Python, whatever's on the left-hand side must be a variable. In this case, x plus 1 is not a variable. X is a variable, but x plus 1 is not, right? X plus 1 is a value. So you're kind of saying, you're telling Python to assign something to a value, and Python doesn't like that. So that's why it's throwing an error. It says cannot assign to operator. So the lesson over here, see from pictures 2 and 3, is that the equal sign in Python means very different thing from the equal sign in math, right? And in math, the second picture would not make sense, but in Python it does. And in math, the third picture would make sense, but in Python it does not. So as long as you get the concepts of, these are the key concepts behind variables, and as long as you get these 3 pictures and try it out in the code, try it out in the console yourself, your understanding of variables should be quite clear, and I hope that is okay so far. Okay, so Similar to math, right? You can actually do arithmetic with variables. So you can, so let's say I have a variable called A and I assign it the value 10, and I have a variable called B and B and I assign it the value 2. Then I can print A divided by B, which just gives you 10 divided by 2, which is 5, right? And I can also, I think someone's mic is not muted. Please mute the mic if you're not asking a question. Thanks. So, and in addition, the usual order of operations rule applies. Brackets comes first, right? And then multiplication comes first. So if I create a variable with A with the value 2, and I write 5 times A plus 6 divided by 2, the 2 plus 6 comes first, and then 5 times 8, right, gives you 40 divided by 2, you get 20. And you might be wondering why didn't I write a print over here? It's because when you're in this console mode, right, then when you don't write a print and your expression is a value, Python automatically prints it out for you. So you can also write this and it behaves the same way. So this is a side note. And lastly, something that will be important for the second lesson is the remainder. You can take a remainder by using the percentage sign. So for example, print 5 modulo 2, right? So this is the remainder operator, the modulo, and I press enter, I get 1 because 5 divided by 2 leaves a remainder of 1. So if I do print 8 modulo 4, I'm just going to get remainder 0. So that this just means remainder. And yeah, so here's a quick checkpoint. I invite you to open the link I put in the chat and paste and write these lines of code yourself. So I'll just give you around 10 seconds to try it out, and then I'll go through, yeah. Okay, so if you guys have gotten a value, you guys can drop it in the chat. Don't be shy. Yeah, so okay, so let's go through it. So so what happens here is that let's create the first line of code, A equals 10 creates a variable named A with the value 10. Yep, that's correct. 2.0 is correct. So then the next line of code, we write B equals to 4. So we create a variable called B with the value 4. We write C equals to 2, create a variable C with the value 2. Then write B equals to B over C. So this line of code, it says B equals, the variable B is reassigned the new value of B over C, which is 4 over 2. So we press enter and we print B. Now we see there is no surprise that B is now 2. So when we see like B equals to B over C, right, this means that we are assigning, as mentioned previously, this means that we're assigning a new value to the variable B. And what is the new value is whatever is on the right hand side of this equal sign, which is B over C, which is at the moment 4 over 2. So that's what the first checkpoint is about. So let's try the second. I invite you to type this at home, right? And let's go through it around now. So the output is going to be 17 because when we set A equals to B times A minus 3, what's the current value of B is 2, right? And what's the current value of A is 10. So 2 times 10 minus 3, print A, we get 17. So just as a quick exercise with variables. And yeah, so now that you've understood the basics of variables, a few side notes is that a few things to note is that when you write a variable, it must be one word, meaning that you cannot have spaces. So you cannot have spaces like this in the first picture because Python will complain. And usually by convention, if we want to use spaces in our variable names, we'll use underscores to indicate spaces. Yeah, and moreover, the variable names in Python, they are case sensitive, meaning that if you have variables, my variable and my variable with capital V, the two variables over here, the two variable names, right, they represent different variables, meaning that they can store different values and Python treats them as completely different variables. So you print the values, you can see that they store different values and it's case sensitive, meaning that they're not related to each other in any way, they're just different. So before I continue, you see this hashtag. Sometimes you see this hashtag in Python, and after that I write some words, usually in English. And what this map represents is just a comment. Basically, this is whatever you write after the hashtag sign, right, in Python is a comment, and Python will not read it as code. So this allows you to like blabber about or explain about what the code is going on. And sometimes you can leave like, you can sort of drop side notes on using these comments, Python comments. And I'll be using it in the following code. So you see when I write your code here, this isn't interpreted as a line of code. This is interpreted as a comment. So Python ignores line 3 over here. Yeah, so now I have some exercises I invite you to try. I think I'll just give you around 1 minute because I think I'm a bit tight on time. So yeah, so if you can just try it out, try to type this code outside and yeah, okay, cool. So Python also recognize Chinese characters as variables. Oh yeah, I think they do, yeah. Although I have never coded in Chinese, to be honest. Yeah, so first one, 8. Okay, yes, indeed, when you, okay, yeah, I'll go through later. Okay, it's been around 1 minute. Don't worry if you have not written all this out yet. Let's just go through. So you see that for the first exercise, it says, so I have two variables, one is called radius, one is called pi, and they've assigned different values like that, 5 and 3.1415. And I want you to create a variable called area and assign it the value of a equal to pi r squared. So there are two ways you can do this, or multiple ways you can do this. One is just creating a new area variable with the value pi times radius and radius. That works also. So another way is let's say you don't want to write it like that, right? You can also create a new variable called r squared and write radius and radius, assign it the value radius and radius, and then you write area equals to pi times this variable. So both achieve the same value for area. And the lesson I want you to learn here is that there are multiple ways to write code to achieve the same behavior. So if you see an exercise, right, and you write code and then you get an output, and then your friend writes a different set of code, right, and he gets an output, it doesn't mean that there's no one correct answer in a sense. As long as your code achieves the same behavior, it is okay. So in coding language, we say that in coding terminology, we say that there's multiple implementations of the same behavior. So yeah, and as you can see that in this case, you probably will prefer the code up here, right? Because it is one more line, whereas the code down here is two more lines. And so sometimes in coding, we say that some implementations are in a sense better or cleaner code, and maybe it's more readable, or maybe it doesn't have that many bugs or edge cases, stuff like that. So point is there's multiple ways to do things in coding, and often they achieve the same result, and that is completely fine. So when you do the exercises, as long as they follow the logic of the intended logic, it is okay to write different code from your friends. So let's go ahead and go through question 2. So let me just clear the console over here. Enter. Okay, so I write a equals to 8. So that creates a variable named a with the value 8. B equals to 64. All right, so that creates another variable. Then write a equals to b over a. So this is really saying a equals to 64 over 8. Right, so if I go ahead and print a now, I'm going to get the value 8. Then I write a equals to b over a again. And so now b has the value 64, a has the value 8. So this is essentially saying a equals to 8. Right, and then I print b is still 64 because I haven't changed the value of b ever since this line, the second line. So I still get 64, right? And then I go ahead and write b equals to a times 10. So what is the value of a? It's currently 8, okay? And the value of, and then 8 times 10, you get 80. So b equals to 80. So now b stores 80. Then I write a equals to b over a. So I assign a new value to the variable a, equal sign, assignment. The right hand side is 80 divided by 8. So now a equals to 10. Then if I write print a times b, so a equals to 10, b equals to 80. So I get 800. And lastly, I write a equals to 3. If I print a, now a, the new value of a is 3. So that's the second exercise. And I'll go ahead and let you try the third one. It's pretty much the same. Yeah, so that is a few exercises. Yeah. So a short mention about variable types is that besides numbers, right, variables can store other things also. So for example, it's common to store text in variables, and to store text, you use these inverted commas to tell Python that you're storing text. It's called a string in Python, right? We call it a string, like string. And that you can also store true or false. These are called booleans, right? Logic. So you must use the capital T and capital F, which will come in useful in the next lesson when we talk about conditionals, if-else statements. And there's also a list, right? You see, there's a list, and we'll be going through that next. So what if you want to store? So great, we have variables, we can store information, and we can process the information using arithmetic, right? And we can reassign the new values to the variables and stuff like that. So we can do computation with variables, but what if you want to have many, many variables? So we can use something called list, which essentially is a bunch of variables. So what does the syntax look like? So the syntax, or how you write the code, is going to be, so you write, similar to how you declare variables, you write the name of the list that you want to declare, and you use equal sign to assign the value to the list. Then you write square brackets, right? And inside the square brackets, you sandwich whatever numbers, whatever elements you want to store inside the list, and they are separated by commas. So for example, I want to store 1, 5, 2, 3. So I write 1, 5, 2, 3. So this creates a list with, when I press enter, this creates a list called my list with four elements, 1, 5, 2, and 3. If I print my list, then I'm going to see that there's 1, 5, 2, and 3. Don't worry about the spacing over here. Internally, Python knows that it's 4 elements. The spacing is just for nicer readability. So someone has a question, why square brackets and not the normal brackets? That's a good question. So thanks for asking the question. So square brackets are used to denote lists. It's just the way Python wants you to do it. If you're asking about, so yeah, you can just take it as you must use square brackets to denote lists. You cannot use 1, 5, 2, 3 because with round brackets, because it just won't work. Why is that so? It's because Python actually use round brackets for functions, and we'll talk about functions more in our second lesson. And for example, right, you see print, right, is actually a function. So that's what the round brackets denotes. It denotes inside the round brackets, you pass in parameters into a function. So yeah, it's just the way Python designed the language. So yeah, thanks for the question. That's a good question actually. So yeah, okay, so now back to list. What if we want to access the what if we want to access the first element of the list? We can use the square brackets and put the index inside. So what is this index? You see that in the code over here, we have print, and then if you want to access the first element, you write the name of the list, right? And then you put the square brackets like that, and you put a sandwich between the square brackets, you put an index. So what is the index? The index is see in this table over here. It allows you to access different elements of the list. So for example, you want to access the first element, it will be index 0. Second element will be index 1. Third element will be index 2. And last element will be index 3. So this is called zero indexing. Basically, instead of counting your elements by first, second, third, fourth, you count it by 0, 1, 2, 3. Yeah, so that's zero indexing is just something in Python that you have to accept. And so if you want to access the first element of the list, you print my list, and then you put square brackets, and because the first element is index 0, you put the number 0. You press enter, you see that we have successfully retrieved the first element in the list, which is number 1. Okay, so likewise, you can retrieve the third element on the list with index 2, like that. So instead of 0, sandwich between the square brackets, you write 2, and we have successfully retrieved the third element of the list, which is number 2. And just like variables, you can also do arithmetic with elements in the list. So for example, I print my list 0 plus my list 3 times 2. So my list 0 is it has value 1. Then my list 3 it has value the third index is the index 3 is the fourth element, which is value 3. So 3 times 2, I get 6. 6 plus 1, right? The first guy is going to be 7. If I press enter, I get the output 7. So that's basic arithmetic with elements in a list. So just, yeah, so arithmetic can be performed on each element in the list, just like a variable. And in fact, you can actually reassign values in the list. So for example, let's say I want to set the first element in the list to be equals to a new value of 2. So I write in my list, I want to reassign the first element. So I write index 0 and equals to 2. So the left-hand side is like a variable like that. And then you write equals, you reassign the variable a new value, and you have 2 on the right-hand side. You press enter, and then you print my list now. You see that the first element has been replaced with the number 2. So now instead of your list being 1523, it's now 2523. So list, right, is really just like a list of variables, as the name suggests. Yeah. So if any questions, you can just shoot them in the chat, as some of you have done. So yeah. So let's say I want to access the last element of the list, right? So what's a clever way to do it? So let's say, let me just clear the screen over here, and let me just define a list called new list. And let's say I want to give it the elements 3, 1, 4, 1, 5, 9, 2, 6. Okay. So if I want to, let's say I want to let's say I want to find the length of the list, I can use a function called length. So I print, right? And inside the round brackets of the print function, I use length new list. So inside this length function, I have another set of round brackets, and inside this round brackets, I write the list that I'm interested in finding the length of. I press enter, I get the length of the list, which is 8, because it has 8 elements, because new list has 8 elements. So that's a way to get the length of the list programmatically using Python. And you see why is this useful? This is useful because let's say we want to access the last element of the list, which in this case is index 7, right? Because there's 8 elements. So 0, 1, 2, 3, 4, 5, 6, 7. The last element is index 7. One way to access the last element of the list is to print new list, and I put index 7 like that, right? And that, you see, successfully retrieves the last element of the list. Yeah, but the problem is that if I use index 7, right, what if my new list now has 10 variables? Then index 7 would not be the last element of the list anymore. Instead, it'll be index 9, right? So a better way to access the last element of the list is to write new list, right? And then inside the square brackets, I write the index, and the index, I want it to be the length of the list minus 1. So length of the list minus 1. So you see that it successfully retrieved the last element of the list. And why is that so? Because length of new list, right, it returns the value 8. And 8 minus 1 is 7, right? So it's effectively accessing index 7. So, and now if I change the length of the list to 10, then length of new list will be 10, and 10 minus 1 will give you 9. So you see that length of using this, right, this other line of code is better because now the length of my list can change, and I'll still be successfully retrieving the last element of this list. So yeah. So I have a question. So are list elements limited to numbers only? For lists, yes, you're only limited to numbers, but actually we'll see something in the next lesson, which is something called, is it next lesson? In lesson 3, we'll see something called dictionary, where your so-called index, right, can actually be strings. So, or they can be like strings, or they can be numbers also, and there can be other data types also. So that's a good question. Your list elements for this first lesson, the list can only have a number as an index, but in subsequent lesson where we see something called the dictionary can have indices that are sort of indices that are not numbers. Yeah, so thanks for the question. That's a good one. So okay, so that's written. So now we see that we can use length of new list minus 1 to obtain the last element, right? But Python actually allows us to take even a greater shortcut. If we write a negative index, right? So if we have a new list equals to 3, 1, 4, 1, 5, 9, 2, 6. And let's say I put a print new list index -1. So what does Python interpret the -1 index as? It interprets it as putting in a length of a new list inside here before that. So it automatically gets me the last element, which is 6. Or if I replace this -1 with, let's say, -2, then it gets me the second last element, which is 2. So that's negative indexing for Python, and you'll see how this is very useful later on. So some additional things you can do with this, you can add elements to the back using this syntax. So you have a list and then you write dot, right, full stop, and you write append, and you put round brackets, and you put the value you want to append to the last of the back of the list. And you see this line of code, after you run it, you get a list, the original list with an additional element at the back of it. You can also delete elements in the list by using the indexing system. So in this case, I've deleted element index 1, which is the value 2. You can also sort the list, right, using the sorted function. So, so this by themselves are cool, but what's a more interesting way to interact with it is using something called for loops. So what if you want to do something repeatedly, you use for loops also. So let's say I have a list, right? And now we'll be moving on to using the editor at the top over here. So now we are no longer using the shell over here. Let's go write code here. So how does code work over here? You can write multiple lines of code and they'll just be interpreted as executing one by one, just like what we have done at the bottom here. So let's say we have a list with values 1, 2, and 1, 3, and 2, right? And let's say I want to append the value 5 to the back of the list 3 times. So one way to do it is just print my list. My list of append 5, and I just copy this line of code and I do it 3 times. And I print my list. After that, I will get, if I press Control and Enter, or I press the green button up here, I'll see that it has printed out 1, 3, 2, 5, 5, 5, which is just 1, 3, the original list with 5 appended 3 times at the back. So this code that you write over here is basically, Python interprets it sequentially. So it goes from line 1 to line 2 to line 3 and so on. Just like how we have typed the code here one by one. Okay, so that's one way to do it. But is there a better way to do it? The answer is using for loops. And so instead of, you want to do something 3 times, right? You want to write a line of code 3 times, you can use a for loop. So how do I write a for loop? I use the keyword for, right? It tells Python that I'm declaring the for loop. So you put a variable name, which is usually related to I. You can name it other stuff also now. So for I, and you write the keyword in, and you write range, and then the number of times you want to run the code inside the for loop. Then when you press, then you write colon, and when you press enter, you see that Python has this IDE has automatically helped you create this blank space over here, right? Don't delete it, because whatever that has this blank space indicates that it's inside the for loop. So for example, I write my list append 5, and let's say I press enter, you see that subsequent lines of code, they all have this blank space over here. It's actually a tab in Python. So if you want to create this space by yourself, you press the tab on your keyboard. Then whatever line of code is here, right? All these subsequent lines of code from line 3 to 8, because they have this spacing over here, they indicate that it's inside the for loop, which means that all this code from line 3 to 8 will be executed 3 times by the for loop. And then whatever that proceeds it without the spacing, without the tab, right, is like line 9 is outside the for loop, meaning that you have exited the for loop already. So yeah, so let's go ahead and run this. So what does I mean? That's a very, very good question, and I'll go through what it means in the next slide. Yeah. So for now, I just take it as that. Okay. So let's press run, and we see that we have successfully appended 5 to the list 3 times. So that's very good. So very good question raised by someone is that what is the I? So the I is actually a variable that the for loop automatically helps you create to keep track of how many times it has run. So let's dissect a for loop by using some print statements. So I write print before, and I write for I in range, just like that one we had just now. And then I print inside, and I print I. So this I is a counter for you to keep track of how many times the for loop has run. So if I go ahead and press this play button here, you see that it prints before, and it prints something, and it prints after. So what does Python do over here? It goes to line 1, right? It prints before. That just output before here. Then it goes into line 2, and then Python sees, hey, you want to start a for loop, and you want to start a for loop with the counter being variable I. So it goes to line, it'll execute line 3 and 4, total of 3 times because there's 3 over here. Then it prints inside, right? And then in the first iteration of the for loop, I will take on the value 0. So we print I, you see that it outputs 0. Okay, then it repeats the for loop. So it repeats whatever is inside the for loop. So it repeats line 3 and 4 again. But in the second iteration, right? In the second iteration, I has the value 1. So you see it prints inside and then it prints 1, which is what we see in the code in the output over here. Then in the third iteration, I has the value 2. So it prints, you see it prints inside and it prints I, which is the value 2. Why we see the output is inside 2 over here. So so now that it has run a total of 3 times, Python exits the for loop and prints, it carries on whatever is in the code after that, which is print after. So this is how the for loop work internally. So to answer your question of what does the I mean, it is a variable, right? The I is a variable to help you keep track of how many times the for loop has run. And you see that this I is very useful because we can use it to do more stuff later on. So if I go ahead and change this to, let's say 10, for I in range 10, then I clear the console and I press run. Then instead of just happening 3 times, I have the for loop happening 10 times with the variable I going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Which is a total of 10 times. So that's what the I means. So why does I count from 0? If you write range 10 like that, it just starts from 0, just like how list starts off with the 0 indexing. And perhaps Python was designed this way, perhaps for loops was designed this way so that it can access elements in the list more easily. But you'll see later, in fact, it's in the next slide, right? It's in the next slide that you can actually start off with the value. You can start off with a value that's not 0, right? Yeah. So for example, you write for I in range 2, 5. The first number you put in is the start, and then the second number is the end. But you must know that if you write 2 and 5, it goes 2, 3, 4. It does not include 5. So it's exclusive of the end variable that you pass, the end value they're passing here. Then the I will take on values 2, 3, 4. So why does it start from 0? The answer is probably designed that way to make accessing the indices in the list more easy. But you can, by all means, you can tell Python to start from a different value that is not 0 if you want. Yeah. So so going back to this slide, if instead of just printing I, right, which is quite boring, let's go ahead and print 3 times I, right, and print I times I. So you can see that with the variable I, that is a counter for us to keep track of the loop execution, we can now do stuff with the variable as well. So in this case, it prints before, right? Then it goes into for loop, executes these 3 lines of code many times, 10 times. And with each iteration, I increments by 1. So you see it prints inside, so it prints inside, then it prints 3 times I. In this case, first iteration, I is equal to 0. So 3 times 0 is 0. Then it prints I times I. So 0 times 0 gives you 0. Then in the next iteration, I has the value 1. So 3 times 1 gives you the value 3, and 1 times 1 gives you the value 1. And then the next iteration, I has the value 2. So 3 times 2 gives you 6, and 2 times 2 gives you 4, right? And so on happens until the last iteration, which is, because it's 10 iterations in total, so the last iteration corresponds to I having a value of 9, which is 3 times 9 is 27, and 9 times 9 is 81. So that is what the I does. And as you see, it's very useful because it's a counter for you. Yeah. And so yeah, that's what you can do with I, the variable I. So this, so as mentioned previously, you can also start off from a different value if you don't want to start from 0. Yeah. So so what can we do with for loops that's very convenient, especially with lists? So you can access all the elements in the list with just 3 lines of code, because with for loops, so let's say I define a list with elements 1, 3, 2, 0, minus 1, minus 0, 1, 0, minus 1, 2. Okay, so 6 elements in the list. All right, a for loop for I in range. And let's say I want to iterate through all the elements in the list. So I need to do it I want the counter I to go from values 0 to 5, right? Because there's 6 elements in the list. So one way to do it is just to write length of the list. And so the length of the list in this case is going to return 6, right? So it's essentially line 2 is saying for I in range 6. And for I in range 6 means that the loop will happen, the code inside the loop will happen 6 times. And for each time, I will increment by 1. So I will go from 0, 1, 2, 3, 4, 5. And see that 0, 1, 2, 3, 4, 5 is very, very conveniently the indices of the list. So you can write print the I element is my list, right? And I open the square brackets, and inside the square brackets, instead of putting a fixed number like 1, 2, 3, or so on, I put I, the variable I, and that's completely okay code. And you press run, you see that now it says the 0th element is 1, and so on, and it has successfully retrieved all the elements in the list just with 3 lines of code. And the beauty of this is that I can add as many more elements I want, and the length of the list will automatically calculate that for me, right? So, and the for I in range will automatically loop through all the elements in the list. So that's the power of using for loops and how you can use it in conjunction with lists to do certain things. So what can we do with it? So, let's say you want to replace all the elements in the list with double its value. So you can just you can define the list, right? Then you have for I in range the list, and then you just say each element, the ith index of the list, right? I want to set it to equals a new value. What is the new value? Is the ith index times 2. So you see that if you write these 3 lines of code over here, you get this output, which has successfully doubled all the elements in the list. So that's just an example of what you can do with for loops and lists. So another thing, as I mentioned previously, you can append stuff to a list, right? So let's try this out. So let's say I want to generate all the Fibonacci numbers, the first 10 Fibonacci numbers, or the first 12, right? And so I create a list with the elements 1 and 1 as the first 2 starting numbers. Then I can write for I in range 10. And then inside the for loop, right, denoted by this space over here, this tab space, inside the for loop, I write fibo.append, right? So I'm adding an element to the back of the list. And what do I want to add? I want to add the second last element plus the first last element. So the last element is going to be fibo retrieved by the index -1. Remember, I previously talked about negative indexing. Then I add it to fibo -2, which is second last element. So if I go ahead and print fibo within the for loop, right? And then at the end of it, I print fibo again. See what happens when I press run. So in the first iteration, right, it adds 1 plus 1 because the element is currently 1, 1. So the last element is 1, the second last element is -1, and it appends it to the fibo list. So when I print fibo, I get 1, 1, 2, right? And then it repeats. Line 3 and 4 repeats because of the indentation over here, telling Python that line 3 and 4 is within the for loop. So in the next iteration, fibo.append adds the last 2 elements, which is currently 2 and 1. And hence when I print fibo, I get 1, 1, 2, 3. It has appended the value 3 to the fibo list. And then this goes on a total of 10 times until it exits the for loop. And then we see when I print fibo, I get the first 12 elements of Fibonacci sequence. So you can see that this is with just effectively 3 lines of code, right? I can generate the Fibonacci numbers to as many places as I want already. So that's the power of automation in Python. Like you can just change this number to like 100 and you generate the first 100 Fibonacci numbers already. So that's the power of for loops and lists together. And yeah, I hope that this is, if you don't understand this example, it's okay. Just note that you can kind of mash together things like that to generate certain behaviors that you want. So lists can also be, for loops can also be nested. So for example, I can write a for loop within a for loop. So what this looks like is there's 1 indentation and then there's 2 indentation, denoting that this print ij is within this j for loop, and then these 2 lines of code is within the I for loop. So in this case, the indices go, I go from 0 to 1, indices j go from 0 to 2 in this particular order, and you print this, you write this line of code and you print the output. I invite you to try it by yourself at home. You get the following output. It's okay if this is a little bit confusing, because I just wanted to highlight that nested for loops is possible, and in fact it's quite powerful. So for example, if you wanted to generate the times table, the multiplication table, up to 6 times 6, up to 5 times 5, you can just write these three lines of code and you get the entire multiplication table like that already. If you want to generate it up to, let's say, 100 times 100, then you just replace the 6 by 101. Then you can generate 10,000, a multiplication table of size 10,000 already. So yeah, that's really the power of for loops. It helps you repeat a certain process, and together with the variable I to help you keep track of the iterations, you can do stuff like that already. So now I am gonna give you, sorry, I know I said 5 minutes here, but I'm gonna say around 2 minutes before actually I'm kind of running. Okay, like 1 minute. Yeah, I'll be going through them together. So don't worry if you cannot finish it. And I have extra exercises if you want to try yourself at home also. So I'll just give you 1 minute to try this out first. Yeah, if you have any questions along the way, please drop in the chat. Okay, so let's go ahead and go through them. So the first exercise is to print meow 30 times. So how do you do that? Is simply you have a for loop, right? You are and for I in range, the number of times you want to do this is 30. So you write 30 within the round brackets, and then you print meow. And if I clear the screen and run this, you see that it successfully printed meow 30 times. So that's just the first one. Then if I go to the next one, so what if I want to generate the first 10 even numbers, then I want to have a for loop with that happens 10 times, right? Because I want 10 even numbers. Then I can, because I is the variable that helps us keep track of the iterations, then I can just do print I times 2, right? And I press enter, I'm going to get 0, 1, 2, 0, 2, 4, 6, so on to 18, right? And this is because the I starts off from 0, right, and ends up at 9. But so which is why we get 0, and which is why we only get up to 18. Then if we want to generate the first 10 positive even numbers, one way to do it is just to write I plus 1 like that. So instead of just having I times 2, I have I plus 1 times 2, and I press enter, you see that I generate it, because then in the first iteration, what's inside this print statement is going to be 0 plus 1, right, which is 1, and then 1 times 2, which is 2. And then the last one, we're going to get 9 plus 1, which is 10, and 10 times 2, which is 20. And alternatively, we can write I over here, but we have to replace this I for I in range. Instead of having 10 over here, we have to write 1 and 11. And so it goes from what, so I will take the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it will not go to 11 because it's exclusive of 11. So if I run this, you see that it also generates the first 10 positive even numbers. So that's, yeah, so that's that. And so let's say I want to print the first 10 square numbers, right? Then I can just replace I times 2 here with I times I. I press enter, you see that it generates the first 10 square numbers. So yeah, that's for those exercises. Um, yeah, so I'm coming to the end of the lesson already. And as exercises, I want you guys to try writing code to calculate the sum from 1 to 100, right? So a small hint, you can use a variable to keep track of the current sum and update it by incrementing its value. And you can use a for loop to go from 1 to 100. Okay, for these extra exercises, I've recorded the lesson for the second, I've recorded the video for the second lesson already. So if you guys want, you guys can check the second lesson, and inside the second lesson, the first few minutes, I went through the extra exercises, so you can see how to do it if you are stuck. Yeah, but I encourage you guys to try it out yourself first, right? Because only through code trying, then you go through the thought process of how do I implement this logic, and then when you stumble upon it, when you stumble and then you see the answer, then it clicks in you. Yeah. So then a second exercise is to negate all the numbers in the list, right? And then the third one is perhaps to reverse a list. You can use negative indexing as a hint. Okay, so now we've reached the rough end of the first lesson. Um, and just some comments is that coding is a skill that you learn by doing. So it's really you may have gone through this lesson and you think, hey, actually that's kind of simple, right? Like for loops happens many times and then the I is just a counter. But even though it looks simple, I really encourage you to give it a try by yourself. And because only when you try, right, then you realize that, hey, actually I've hit don't fully understand this thing over here. And when you meet bugs, then that's where you really learn. And if you cannot solve the bugs by yourself, then please ask me, because that's what I'm here for. And I'll be more than happy to help, because the goal of my lessons is to help as many people get introduced to Python as possible. And if you are asking me for help, then that means that my job is successful. I've done a good job. So please ask me for help. Don't be embarrassed. Yeah, just ask me on Telegram. Then resources are also quite abundant. So for example, if you want to learn coding to build a website, you can also ask me. I can show you some resources where you can build a website using Python. Yeah, and it's really more of the challenge in most of coding is really less of finding the resources and more of understanding and distilling through the resources, because resources are a lot. It's just whether you are able to process and digest them. And if you have just decided to try this course, uh, just to open your eyes, and you have lost interest already, then I mean I'm sad, but if you don't want to come next week, it's perfectly okay. Yeah, I won't force you. But I suggest you at least try to give it a try, because the more you know, the more fun it gets. And yeah, if not, I hope to see you guys next week. And if any questions, please ask me. Yeah, that's the end of the lesson. So yeah, thank you. Yeah, have a nice day. Bye bye. Thank you. You too. Okay, bye. Bye bye. Thank you. Have a nice day. Bye bye. Thank you. Bye.